In this video, I'm going to show you how to work out exact values for 30 degrees, 45 degrees and 60 degree angles. It's very important that you are either able to recall these from memory or are able to work them out, because they are used a lot in paper 1 questions. You can easily work them out. So the first thing you need to do, I'm going to work out 30 and 60 degrees. So first thing you need to do, draw yourself an equilateral triangle. The one good thing about an equilateral triangle, we know that all the angles are 60 degrees. So I'm going to drop a perpendicular bisector down from the top vertex, and that will cut the triangle in two. So these original triangles had sides 2 units. So now I've got an angle of 30 degrees there. So I've got a right-angled triangle, which I'll draw on the side. So I know that this angle is 60. I know that that side is 2. This is half of 2, so it's 1. And then using Pythagoras, if I use Pythagoras, that works out to be root 3. So that is 30 degrees. So now I can work out. So let's do the sines first. I'm going to use 30 degrees. So sine 30 degrees. Remember, sine is opposite over hypotenuse. So that is equal to a half. Now do cos 30 degrees. So remember, that is adjacent over hypotenuse. So that's root 3 over 2. Now let's do sine 60 degrees. So sine 60 degrees is root 3 over 2. Now do cos 60 degrees. So cos 60 degrees is 1 over 2. Now let's work out tan. We know that tan theta is equal to sine theta over cos theta. Therefore, tan 30 equals sine 30 over cos 30. Which equals a half divided by root 3 over 2, which equals 1 over root 3. I'm now going to multiply the top and bottom by root 3 because I don't like surds on the bottom. So that will give me root 3 over 3. Now let's do tan 60 degrees. So tan 60 is sine 60 over cos 60, which is equal to root 3 over 2 divided by a half, which is equal to root 3. So now we have sine 30 degrees is a half, cos 30 degrees is root 3 over 2, sine 60 degrees is root 3 over 2, cos 60 degrees is a half, tan 30 degrees is root 3 over 3, and tan 60 degrees is root 3. And that is all derived from an original equilateral triangles whose sides are 2 units in length. You can do exactly the same for 45 degrees, but this time you start with an isosceles right triangle. So let's draw an isosceles right triangle. Because it is an isosceles right triangle, we know that these two angles are 45 degrees. And we know that these two lengths are the same, so they're length 1. Using Pythagoras, the hypotenuse must then be root 2. So we can now work out sine 45 degrees is 1 over root 2. Again, I don't like surds on the bottom, so I'm going to multiply the top and bottom by root 2. So that will give me root 2 over 2. So cos 45 degrees is again 1 over root 2, which is root 2 over 2. And then tan 45 degrees is sine 45 degrees over cos 45 degrees, which is equal to root 2 over 2 divided by root 2 over 2, which is equal to 1. So sine 45 degrees is root 2 over 2, cos 45 degrees is root 2 over 2, and tan 45 degrees is equal to 1. You have to be able to derive all these angles, or you need to memorize them so they can be used in paper 1 questions in the exams.